Hello, this is the Autumn 2 Week 5 exam practice marking video on the greenhouse effect and global warming. Let's get going. Global warming is thought to be happening because of the increased burning of fossil fuels. The concentration of carbon dioxide in the air from 1905 to 2005 has been calculated. So it's so easy to see here that from 1905 to 2005 there's been a massive increase in the concentration of carbon dioxide. Draw a line of best fit for these points. Okay, so it doesn't need to touch every point, but it should show the general pattern. Oh, that was a bit wonky. You get the idea though. In what year, oh no, sorry, in what was the concentration of carbon dioxide in 1955? 1955, I will draw on this from the x-axis up to the point there, and then along, so like halfway between both squares. And to zoom in, you can see that between 310 and 320 there are 5 squares. So between 320 and 310 there's a difference in 10 for concentration, and there's 5 squares, so 10 is represented by 5 squares, so shouldn't have done that there, by 5 squares, so 1 divide by 5, divide by 5, what am I talking about, divide by 10, and to do the same on this side, divide by 10, so we get 0.5, so for every 10 there's 5 squares, for every 1 there's 0.5 squares. Now there's 1.5 squares up from 310, so 1.5 squares up, so multiplied by 3, so I'll multiply by 3 on this side, and that tells me that 1.5 squares is equivalent to 3, so 310 plus 3 equals 313, which is the concentration of carbon dioxide. 313, which is the concentration of carbon dioxide in 1955. In which year did the concentration reach 350 parts per million? That's what that unit means, by the way. You don't need to know it, but it means parts per million. 350, I'm just going to check. Yeah, okay, so 350, it's right here, it's very clear. I'm a poet, I didn't know it. Let's just follow along, and then we'll follow down. Ideally not really to use a pen when you're doing this, because it just runs. Okay, so between 1985 and 1995, so 1995, 1985, so just 10 years, it's shown by 5 squares, so 10 years is equal to 5 squares. 1 year, again we're doing the same thing, divided by 10, is equal to half a year. Sorry, 1 year is equal to half a square. Now we're 2 squares along, so half a square is equal to 1 year, so 2 squares. Obviously you might just be intuitively get this, but this is for people who don't. Is equal to 4 years. So 1985, 2 squares along, add another 4 years, it's 1989. That in 1989 the concentration of carbon dioxide was 350 parts per million. Now, if you put 1988 or 1990, that will allow you to have the mark. Next, use the graph to describe a as much detail as you can what happened to the concentration of carbon dioxide from 1905 to 2005. So you can see that it increased. Now if I use my ruler to show the gradient, it's not that steep in the early 1900s. In the mid 20th century it gets steeper, but towards the end of the 20th century, towards the start of the 21st century, there's a huge increase. So whilst all along over that century there is an increase in carbon dioxide concentration, the rate of increase increases towards the end of that time. So the concentration of carbon dioxide has increased for one mark, but for the second mark, in recent years the rate of increase has increased. Complete the following sentence. The main process that has caused the change in carbon dioxide is the burning of fossil fuels. You get a mark if you name the fossil fuel like coal, oil or natural gas. The table shows the gases in the Earth's atmosphere today. So nitrogen, oxygen, argon, other, so that could be carbon dioxide, helium for example. What's the percentage of X? Okay, so we've got 78 plus 21 plus 0.9 plus X, which would equal 100. Now all of these equal 99.9, so we're just missing 0.1 to bring it up to 100, and that's why the answer is 0.1. Okay, here is data that we need to plot the data from the table onto figure 2. So the only piece of data that's missing is about oxygen at 21%. So here we've got 20 to 30, that's just an increase in 10%, which is equivalent to 1, 2, 3, 4, 5 squares. So going to 1 would be equivalent to 0.5 squares. Now I did that because we want 21, so we need to go half a square above 20, and it needs to be just over 1 centimetre wide, so it doesn't look really strange. That's about halfway up from 20, and that's oxygen. So the majority of the gas in the Earth's atmosphere is nitrogen, then oxygen, and a small amount of argon and trace gases. That question, I forgot to actually ask the question, so ignore that. Okay, and this is in the atmosphere of Mars. So loads of carbon dioxide, a little bit of nitrogen, a little bit of oxygen. Now, if we compare this, Mars's atmosphere contains over 90% of carbon dioxide. Now, carbon dioxide doesn't even make it onto this graph because there's only trace amounts, so very little in Earth's atmosphere. Mars's atmosphere contains less nitrogen, so about 2%. Here, almost 80%. Last but not least, Mars's atmosphere contains less oxygen, like not even, well maybe that's a percent, yeah, compared to 21%. So there's a huge difference. Some theories suggest that the Earth's early atmosphere was the same as the atmosphere of Mars today, so massively different. Describe the change in the percentage of oxygen from Earth's early atmosphere to today. Well, one thing I've said is the percentage of value of oxygen has increased from around 2% to around 21%. You could have talked about the amount of nitrogen increasing, you could have talked about the decrease in carbon dioxide. Okay, percentage of greenhouse gases from human activities. So we can see, whoa, electricity and industry, so that's like factories, contribute loads to greenhouse gases. I'll just put GG for greenhouse gases. And transport contributes the least. Now, don't think you can just get away with getting in your mum's car to school because of that, because public transport would reduce how much transport contributes to greenhouse gases even more. Compare the contribution of each activity to the total amount of greenhouse gases. Use data from figure 4. So I said using electricity and industry are the highest contributors of greenhouse gas. Electricity and industry contribute equally. Transport contributes only to 15% of the total amount of greenhouse gases, which is half that of electricity and industry, and transport overall is the lowest contributor of greenhouse gases in the Earth's atmosphere. Suggest one way that greenhouse gas emissions could be reduced. So, use energy resources that are renewable. Or you could have actually said an example, so use solar energy instead of fossil fuels. Use wind energy. Use hydroelectric energy. Or suggestions like use cars less, decide to get the bus, like public transport instead of a private vehicle. Give one reason why it's difficult for some countries to reduce emissions of greenhouse gases. So, well, first of all, some less economically developed countries might have limited investment in renewable energy, so they might not have wind turbines, they might not have dams. So that could be a reason. Or disagreements between countries, so some countries might not think it's a priority. Human activities can affect our ecosystem. Figure 5 shows about how the area of ocean with sea ice, so ice caps, in the Arctic has changed between 1979 and 2016. Okay, what does this mean? Let's have a look. So this is 1979. So all the way throughout the year, in 1979, there was more sea ice covering the area of ocean. Now if we have a look, this tiny dashed line is 2016. So for 2016, it follows the same pattern of lots of sea ice around the winter months like January and February, very little around late August, September, October. But actually, there's for every month in 2016 far less ocean covered with sea ice than there was in 1979. That's a shame, poor polar bears. State 2 conclusions that you could make from the data shown in figure 5. 1. February and March are the times of the year when sea ice covers the most area of ocean. Sea ice covers the smallest area from September to October, so only like 4 kilometres squared to around 14 in winter. Across my team. Next question. The area of ocean with sea ice in the Arctic has changed. Most scientists believe that this is due to the activities of humans. Explain the activities of humans that have led to the changes in sea ice from 1979 to 2016. Look at where I've bugged. So I want us to explain the activities of humans that causes the area of sea ice to change. So, deforestation limits photosynthesis, causing increases in carbon dioxide. Because remember, photosynthesis takes in carbon dioxide, which is a reactant of photosynthesis. There's increasing amounts of fossil fuels being combusted, which releases more carbon dioxide into the atmosphere. So, more carbon dioxide in the atmosphere. Now, greenhouse gases like carbon dioxide absorb long wavelength radiation, which is then radiated back to Earth, which warms the Earth's surface, causing sea ice to melt. It says 1, 2, 3, 4, 5, 6 points for a 6-mark question. Pause it now if you need to write it down. Learn that by heart. There is less carbon dioxide in the Earth's atmosphere now than there was in the Earth's early atmosphere. The amount of carbon dioxide in the Earth's early atmosphere decreased because it was used by plants and algae for photosynthesis, dissolved in the oceans, from fossil fuels. Give another way that the amount of carbon dioxide in the Earth's early atmosphere decreased. it forms sedimentary rocks such as limestone. Now limestone has the chemical formula CaCO3, so you can see that carbon and oxygen from carbon dioxide formed limestone. So it's locked up in that instead of being in the atmosphere. Now these 4 different ways or reasons why the amount of carbon dioxide decreased from the Earth's early atmosphere to now, you need to know them by heart. Carbon dioxide is a greenhouse gas. Describe the greenhouse effect. Okay, so this is a shortened version of this, so it doesn't have about the deforestation and combustion of fossil fuels, but it's got more detail of the greenhouse effect. So there's a build-up of greenhouse gases in the atmosphere, so that's because of deforestation and combustion of fossil fuels and other things. Short wavelength radiation passes through the atmosphere, so that's fine, to the Earth's surface. Greenhouse gases absorb long wavelength radiation that otherwise wouldn't be absorbed and re-radiate it, so send it back down to Earth, which causes an increase in the Earth's temperature. Learn that as well. And Merry Christmas.